Hey everyone, Mr. Phil's Avatar here with another Devlog update. Yesterday, I'm covering a massive surge of progress on Stellar Throne, my 4X strategy game. For context, I'm building this with Godot for the UI client and Zig for the high-performance simulation engine. After the previous day's visual data preservation work validated that the dual engine architecture was functioning correctly, yesterday focused on systematically fixing crackle bugs and implementing major missing systems. The day started with an interesting problem. Fleets would stop at their first waypoint instead of continuing to their final destination. If I ordered a fleet to travel across 5-star systems to reach a distant colony, it would jump to the first star and then just sit there, ignoring the remaining 4 hops in its route. The bug had 2 root causes. First, the Zig simulation backend was missing multi-hop continuation logic entirely. When a fleet arrived at a waypoint, the code would mark it as arrived, but wouldn't check if there were additional destinations in the route. Second, the has-planned route flag wasn't being properly set during deserialization. The Godot serialization layer doesn't explicitly send this flag. It's supposed to be inferred from whether the route array is non-empty. I fixed this by adding multi-hop continuation logic to the Zig fleet arrival handler. When a fleet reaches a waypoint, the code now checks if there are remaining destinations in the route array. If there are, it initiates the next jump immediately. I also fixed the deserialization to properly set has-planned route to true whenever a fleet has a non-empty route array. Fleets now correctly travel through all waypoints to reach distant destinations. Then I discovered a major configuration loading bug that was preventing game events from triggering. There's a Salvage the Past event that's supposed to fire at the start of every new game. It provides narrative context and a small resource bonus for the player's starting empire. But this event was never appearing. The problem was that the event manager was still loading events from a deprecated JSON file instead of using the shared TOML configuration system. The project had migrated all configuration data to TOML months ago to enable sharing definitions between Godot and Zig, but Event Manager was never updated to use the new loader. It was still pointing at an old JSON file that no longer existed. I fixed this by removing the hard-coded events config path and replacing the load event definitions method to use config manager's TOML loader instead. This required adding format conversion because the TOML uses snake case field names while Godot expects camel case internally. But that conversion is handled automatically by the config manager. However, fixing that revealed an auto-load order dependency issue. Event Manager depends on Config Manager to load events from TOML, but Config Manager was loading after Event Manager in the auto-load sequence. This caused Event Manager to initialize with an empty events dictionary because the TOML files hadn't been loaded yet. I fixed this by moving Config Manager to position 5 in the auto-load order, after core systems, but before game state. This ensures all TOML configs are loaded before any managers that depend on them. The Salvage the Past event now triggers correctly at game start. Next, I tackled a critical bug with the research system. Research was completing at 100% progress, but then persistence would break. After saving and loading a game, the research progress would be corrupted. Sometimes active research would lose all progress. Other times, completed text would show as still in progress. The research system was fundamentally broken when using the Zig backend. This turned out to be multiple layered bugs. First, there was a serialization key mismatch. Godot was sending active tech, but Zig was expecting active tech ID. Second, the Zig deserialization wasn't properly reading research data from the nested research state dictionary structure. Third, tech completion wasn't clearing the progress tracking, causing progress to accumulate over 100%. Fourth, the Zig serialization was using a flat structure instead of the nested research state and tech modifiers dictionaries that Godot expects. I fixed all 4 issues with extensive changes to Research State, Sim Empire, and Turn Simulator. Research now persists correctly across save load cycles and properly clears completed tech progress. But there was an even bigger problem hiding beneath those bugs. Research wasn't actually completing at the correct cost values. Techs were completing at arbitrary progress thresholds that didn't match the costs defined in the TOML configuration. A tech that should cost 450 research was completing at 300. Another that should cost 600 was completing at 250. This was because the Zig getTech function was using broken tier matching logic instead of proper tech ID lookups. It was trying to infer tech cost from the research tier instead of looking up the actual cost from the loaded TOML configuration. I replaced this with proper ID mapping that converts the integer tech ID to its TOML string ID and retrieves the real cost from the loaded config. That fix revealed yet another problem. Tech effects weren't being applied when research completed. When a player finished researching a technology, they should get modifiers like increased sensor range or production bonuses, and they should unlock new buildings or ship types. But nothing was happening when techs completed under the Zig backend. This is because the Zig complete tech function is marked as simplified and doesn't implement tech effect application yet. It only unlocks the tech ID. It doesn't apply modifiers or unlocks or send notifications. I implemented a workaround by adding post-processing in Turn Simulation service. After the Zig simulation runs and deserializes the new game state, the service now detects newly completed techs by comparing the unlocked tech set before and after. For any new completions, it calls Research Manager's Apply Technology Effects method to handle modifiers, unlocks, and notifications on the Godot side. This is a temporary solution. I documented the proper implementation approach in a new file called TODO_tech_effects.md. which outlines how to implement full tech effect application in the Zig backend. That work is estimated at 15 to 20 hours, but the workaround is functional. Research now completes at the correct costs and applies all tech effects properly. After fixing all these immediate bugs, I shifted focus to long-term planning. The Zig simulation backend currently has 10 simplified systems: construction, combat, AI, events, advanced mechanics, and victory conditions are all marked as simplified or not yet implemented. These systems work at a basic level, but don't have parity with the full Godot implementations. I created a comprehensive implementation plan across 5 new planning documents. The Zig implementation plan provides a detailed 13-week roadmap with phase-by-phase breakdowns for all 10 simplified systems, including data structures, algorithms, integration requirements, and effort estimates totaling 360 to 450 hours. The Zig Parity Roadmap provides an executive summary analyzing the current state, 8 systems fully implemented, 10 simplified, and explains why the current parity tests with 65% tolerance are inadequate. True parity requires zero tolerance testing with less than 0.01% deviation. The Parity Test Examples document provides concrete test specifications showing exactly how to implement construction parity tests, combat parity tests, AI parity tests, and event parity tests with deterministic RNG seeding and exact state matching across 100 turn integration tests. The Zig Parity Progress document provides session-by-session progress tracking with milestone checklists, time tracking, velocity metrics, and decision logs. And the Session Workflow Guide provides start during end session checklists to keep the multi-week implementation organized. Then I implemented Phase 5, the construction system. This enables turn-based building construction and production-based ship construction in the Zig simulation backend. I created simconstruction.zig with construction order and construction queue data structures, extended Sim Galaxy with building queues and ship queues, and implemented construction processing in Turn Simulator. Construction orders track 13 fields, including construction progress, turns required, turns elapsed, production progress, and resource costs. Construction queues provide FIFO ordering with add order, remove order, and get first order methods. The processing logic handles turn-based building construction, where turns elapsed increments each turn, and production-based ship construction, where production progress accumulates based on shipyard output. When buildings complete, they're added to the planet with proper sim building initialization. When ships complete, they're log only. Actual ship creation is simplified for now. The system includes full bidirectional serialization between Zig and Godot for save load compatibility. This implementation took 8 hours versus the 12 to 16 hour estimate, 33% ahead of schedule. All 339 Zig unit tests are passing, and 739 out of 740 GUT integration tests are passing. That brings Zig parity to 1 out of 7 phases complete, or 14% overall progress. But construction exposed 3 critical bugs that prevented it from working correctly across turn processing. First, construction orders were disappearing after running a turn. The root cause was that planet.systemid wasn't being set during deserialization. When the Zig simulation tried to look up construction queues by system ID, it couldn't find them because planets didn't know which system they belonged to. I fixed this by ensuring star systems from dict method sets planet.systemid. Second, building names were showing as unknown building instead of the actual building type. The Zig simulation couldn't deserialize item type strings correctly, causing the building type to be lost. I implemented a workaround where construction queues are saved before Zig simulation runs and restored after, bypassing Zig serialization entirely. This is temporary until Zig implements construction processing. Third, the wrong building was being created. Players would queue up a power plant but get a colony hub instead. This was caused by empty item type fields triggering incorrect building creation logic. The construction state preservation workaround fixes this by ensuring building types are preserved exactly. Finally, I implemented a resume system with automatic session archival. The resume.md file had grown to over 2,000 lines and was consuming massive amounts of context. I archived sessions 1 through 59 to a separate archive file, implemented a rolling free session window in resume.md, and created specialized Claude agents for proactive resume management. The resume writer agent proactively updates resume.md when context exceeds 150,000 tokens, or when the user says, "Done for today." The resume reader agent provides quick project status summaries at session start. This reduced resume.md from 2,000 lines to 400 lines, an 80% reduction in context usage, while maintaining searchable historical archives. Let me give you the technical breakdown. Yesterday produced 13 commits with massive changes. The fleet multi-hop fix touched 2 Zig files with 34 lines of continuation logic. The event system TOML migration modified event manager with 63 lines. The autoloan order fix was 1 line, but critical for dependency resolution. The research persistence fixes touched 4 files with 128 lines. The tech cost fix replaced 41 lines of broken tier logic. The tech effects workaround added 53 lines of post-processing. The planning documents added 5 new MD files, totaling over 2,000 lines of roadmap and tracking infrastructure. The Phase 5 construction implementation added 454 lines of Zig code across 3 files. The construction bug fixes touched 6 files with 108 lines. And the resume system restructuring archived 1,500 lines and added 2 specialized Claude agents. Current status. Research completes at correct costs and applies tech effects. Events trigger properly at game start. Fleets travel through multi-hop routes correctly. Construction system is fully implemented in Zig, with 1 out of 7 phases complete. The implementation plan provides a clear 13-week roadmap to achieve 100% Zig parity. The resume system keeps documentation manageable for long-running development. This represents a fundamental shift from fixing bugs in the Zig backend to systematically implementing missing Zig systems. The planning documents provide structure for the next 3 to 4 months of work to achieve production-ready complete Zig simulation. Phase 9, combat resolution, is next, estimated at 24 to 32 hours. That's the development update. Check out MrPhilGames.com for more. Thanks for watching.